Alright, we are going into a little bit of a review mode. We've been working on matrices, and before that we were doing systems. And there's a test coming that's going to involve a lot of matrices, but also some systems. So we need to go back and remember some of the stuff we learned before. Now, originally I had, in the directions, I had said to do number 3 using matrices, but this has a determinant of 0. So that means it's not invertible. You cannot find the inverse when you set up the coefficient matrix. So using matrices will not really work out for us very well. So let's go back and use a different method, like, for example, elimination. Let's see. Let's say if I want to get rid of the x's, I might multiply the top equation by -5. Then this will become -5x plus 10y is equal to -30. Now the bottom equation can just stay what it is, okay, because it didn't get multiplied by anything. So that's just going to stay 5x minus 10y is equal to 3. But what happens is everything cancels out, not just the x's, but the y's also cancel out. So that's going to leave me with 0 over here. 0 equals -27. So the question is this going to be no solution or infinitely many solutions? Well, hopefully you remember that this is your no solution. I meant to put the arrow this way. This is your no solution scenario. And it comes down to if these numbers are different. If you have a false statement, like 0 equals -27, 0 does not equal -27. That's wrong. It's so wrong that there's no solution. On the other hand, so that's it. The answer number 3 is no solution. But on the other hand, let's say this had turned out to be +30. It wasn't, but what if it had? Then the -30 and the +30 would have canceled out. Then I would have gotten 0 equals 0. This would be your infinitely many. Solutions. Infinitely many solutions in this case. That's not what happened this time, but it could have. So please remember that will still be on the test. Okay, I put back that the way it was. Alright, let's move on. Okay, so looking at number 5, graphing this inequality. Well, if you want to graph an inequality, the thing to do is to get the y by itself. And I would do that by multiplying both sides by 3. Okay, that is going to give me y, well, I almost put equals. Y is less than or equal to 6, because the 3's cancel out. Well, in your mind, if you remember about y equals 6, hopefully you remember that this is a horizontal line. Y equals a number is a horizontal line. Okay, so y equals 6 would be this line right here. Okay, it's a horizontal line at 6. Because of the or equal to, we can keep it as a solid line. Okay, so there will be the line y equals 6. Now, because it's less than or equal to 6, I'm going to shade on this side of the line. Okay, so if I shade that in, then I'm done. Now just be careful when you do your shading, okay, on this side of the line. One mistake I see kids make is they will think that the x-axis is some sort of a barrier, and they will stop, like here. If I see this, I'm marking it wrong. Okay, the x-axis is irrelevant. Okay, you're supposed to be shading in everything that is less than the line, everything down to the edge of the graph. Okay, so that is what number 5 should look like. Moving on to number 9. graphing the system of inequalities. All right, so let me color code. So I'll graph this one in blue. Okay, so when I think about y equals 2x minus 5, what I see is I've got that -5 is my y-intercept. So that'd be like right there. And then the 2 is like the slope. So that's like 2 over 1. Okay, so that means it's going to be up 2 over 1, like this. Okay, up 2 over 1, over and over and over again. And I can repeat like this, going down 2, back 1. So I'm going to go ahead and draw this line. Now, notice that this is not or equal to. So this should be a dotted line. And notice that it's greater than, by the way. So this should be a dotted line, so make sure you show a dotted line for it. Okay, I'm going to go ahead and make it blue like I said I would. I'm going to make it dotted like I said I would. Okay, now also because it is greater than, I'm going to shade above this line. Think above and below. And but don't go crazy and shade all this stuff in. Just put a little bit of shading, okay, like grass growing on the above side of this line. That will remind me later to shade the above side of that line. Anyway, moving on. Next, we have x is greater than or equal to -1. I'll do this one in red. Okay, please understand that this is going to be a vertical line. X equals a number is a vertical line. All right, so I'm going to start off by graphing x equals -1, which is a vertical line at -1, like this. Okay, probably should have put arrows on that. I'll worry about that later. Now it's greater than or equal to, so it gets to stay a solid line. I just need to do the greater than part. But first I'm going to make it red. Now, because it's greater than, this is the one time that I don't do above and below. There is no above and below for a vertical line. So I will do left and right. The greater x values are to the right. So we will shade on this side of the line. And again, just put a little bit of grass growing sideways on this side of the line. Okay, so far that makes our feasible region inside this V right here, okay, in the top. All right, that's what satisfies the blue and the red. But there is one more inequality, and that is this one. Y is less than or equal to 3. I'll do this one in purple. Again, I'm thinking y equals 3 because I have to graph that. Y equals a number is a horizontal line, like this. So I need a horizontal line at 3. Okay, that's going to look like this. All right, I remembered my arrows this time. So horizontal line at 3. Let's make it purple. And this one is less than or equal to. So I will shade below. Okay, like this. All right, now I will shade in the area that satisfies all 3 inequalities. Okay, so this will be the feasible region. These are the solutions. This is the solution area. Okay, and that is how you do number 9. Okay, now number 11. Better back on up a little bit for a second. Well, no. Find the minimum and maximum values of the objective function subject to these constraints. Okay, I better stay close actually. Okay, well, all right, we need to graph the inequality. So first of all, we have the little reality constraints. X is greater than or equal to 0. Y is greater than or equal to 0. And luckily that's true because I only gave you the first quadrant. But your x is greater than or equal to 0, okay, would be this vertical line. This is your x is greater than or equal to 0. Okay? And the horizontal line here, that's your y is greater than or equal to 0. So it just means we have to be in the first quadrant here. Okay, in this area. So that takes care of those two. Now let's deal with the other two equations. I'm going to do this one in blue. Okay, this will be my blue one. And we need to get y by itself. So let's add 3x to both sides. So that'll give me 6y is less than or equal to 3x plus 18. But then I needed to divide everything by 6. So divide by 6. So that's going to give me y is less than or equal to 1/2 x plus 3. Alright, so that's my first equation. So y-intercept of 3 and then 1/2. Let me see if this will fit on this graph. I'm going to risk it. I may have to erase it if something doesn't fit. So y-intercept of 3 and then up 1 over 2 like this. Okay, and I can go ahead and draw a solid line. And it is less than or equal to, so I will shade below this line because it's less than or equal to. Just a little bit, just grass growing upside down. So that is the first one. So far that puts me in this area right here, but let's see what else we have. Alright, we have one more inequality, and I will do this one in red. Still trying to get y by itself, so let's subtract x from both sides. So that's going to give me y is less than or equal to negative x plus 6. So there's 3, 4, 5, 6. Negative x, that's like negative 1 over 1. So down 1, right 1. Like that. It's equal to, so I can make a solid line again. Alright, it's less than or equal to, so I will shade a little bit on the below side of the line. Upside down grass. Okay, so I can see that this area right here is the feasible region that satisfies all 4 inequalities or constraints. So kabam, this is the feasible region right here. We're going to need to talk about the vertices so that we can evaluate the maximum and minimum of this objective function. Did it say max and min? Yeah, max and min. So we need these vertices, as you recall. So of course this is 0, 0. This one is 0, 3. This one is 2, 4. And this one is 1, 2, 3, 4, 5, 6, 0. Alright, these are the 4 points we're going to deal with. Alright, so let's do our objective function right now. So this is the objective function, okay? It's c equals 3x plus 5y. So let's put these points in one at a time. So we're going to do 0, 0, 0, 3, 2, 4, and 6, 0. Okay, so this will become 3 times 0 plus 5 times 0, which of course is 0. And this will be 3 times 0 plus 5 times 3. That's 15. This one is 3 times 2 plus 5 times 4. 5 times 4 is 20 plus 6, so that is 26. And the last one is 3 times 6 plus 5 times 0, so that is 18. Okay, so we're dealing with a maximum of 26, which is coming from 2, 4, and we're dealing with a minimum of 0, which of course is coming from 0, 0. So we just need to write that down. Okay, so we have a max of 26, which occurs at the point 2, 4, and we have a minimum of 0 from the point 0, 0. All right, it's been a while since we did that, so get that back in the front of your brain. That you're still responsible for that for this upcoming test. Okay, let us move on. Using the given matrices, evaluate the expression. So we need to do A plus 2 times B. We're still going to follow the order of operations. You know PEMDAS? Please excuse my dear Aunt Sally. So we're going to do this multiplication before we add. So matrix A is this -1, 3, -4, 5 business. But 2 times matrix B, if we go ahead and multiply all this by 2, that's going to give me 0, 4, 6, and -8. See what I did there? I took 2 and I multiplied everything by 2. Now I can go ahead and add, and that's going to give me -1. I'm just adding these corresponding entries. So -1 plus 0, 3 and 4 make 7. -4 and 6 make 2. 5 and -8 make -3. Okay, so this would be the answer for number 15. Let's see, what else I got over here? Number 17. The first thing in the order of operation is parentheses. That means if there's something inside of the parentheses that you can do, you should do that first. So we're going to do matrix A later, but first we need to figure out what B plus C is. Okay, so B plus C, okay, I'm just going to go ahead and add these right now. Alright, in fact, maybe I'll just go ahead and write down matrix A for that matter. So we've got -1, 3, -4, 5. Okay, that's matrix A. Okay, matrix B plus C, okay, is going to be -7. Okay, I'm adding those up. 2 and -2 make 0. 3 and 0 make 3. -4 and -3 make -7. Okay, so this green matrix is B plus C. Alright, and this purple matrix is matrix A. So now we're going to do A times B plus C. Okay, so please remember how we do that. Well, this is first of all, what you don't do, you do not just multiply corresponding entries. I will not just do -1 times -7 and -4 times 3 or anything like that. This is a 2 by 2 matrix, and this is also a 2 by 2 matrix. Because the inner dimensions are the same, I know that it's possible to multiply. But the outer dimensions are what tell me what the shape of the answer is going to be. So my answer is going to be of the form 2 by 2. So this is going to give me some sort of a 2 by 2 matrix, which I like to label. All right? Element 1, 1. Element 1, 2. Okay, that's row 1, column 1, and this is row 1, column 2. Keep going. This is element 2, 1, and this is element 2, 2. Because this is row 2, column 1, and this is row 2, column 2. Okay, so I just need to find these 4 elements and fill them in, and that will be my answer. Okay, I think I'm going to use some of this space up here. So if I want to find element 1, 1, for example, 1, 1 means row 1 times column 1. Okay, now that's row 1 from the first matrix, column 1 for the second matrix. So I have to do -1 and 3, that's row 1, and -7 and 3, that's column 1. I will multiply and add. So this is going to give me +7 and 9, so that's going to give me 16. Okay, so that means element 1, 1 is 16. I'll go ahead and show it instead of erasing. All right, so that'll be 16 so far. I just need to do that 3 more times. So over here, I feel like I should change colors. All right, how about element 1, 2? Okay, element 1, 2. That's row 1 times column 2. So row 1 is -1, 3. Column 2 is 0, -7. If I multiply those together, I get 0. Well, that was close. Anything times 0 is 0, and -21. So that makes -21 when I add those up. So that means this is -21. All right, let's do it again. This time, let's find element 2, 1. So element 2, 1. That is row 2 times column 1. That's -4, 5, and -7, 3. So that's +28 and 15. That's going to make, let's see, was that 13 and 40, so that's 43. Okay, so that's element 2, 1, so this is 43. And last but not least, we need element 2, 2. So let's find that. Element 2, 2 will be row 2 times column 2. So row 2, so that's -4, 5 times column 2. So that is 0, -7. That's going to give me 0 and -35, which gives you -35. Okay, so this should be the answer. So we added B and C, then we multiplied A times that, so boom, there you go. This is a nice little review, man. You're going to have to do all this stuff on the test, you guys. Okay, anything else hiding over here? No. So let's move on. What else you got? Evaluate the determinant. Okay, nice, easy ones. Remember that the determinant of a 2 by 2 matrix, that's when we do the down diagonal minus the up diagonal. So I'm going to do this yellow diagonal minus this blue diagonal. Okay, that's how you do the determinant of a 2 by 2. So that is going to be, okay, I'm doing -5 times 6, that's the down diagonal, minus -4 times -7. So that is -30 minus 28. So that is going to be -58. So that is it. That's the determinant for number 19. Okay, finding the determinant of a 3 by 3 matrix takes a little bit more doing. This is the one where we have to recopy the first two columns. So over here I'm going to have 3, -4, and 5. And then I'm going to have 0, and 6, and -1. Now, we're still going to do down diagonal minus up diagonal, but this time there will be 3 of them. Okay, so the down diagonals are this, and this, and this. Okay, so as I do my down diagonals minus my up diagonals, 3 times 6 is 18 times 1. 0 times anything is 0. Okay, 2 times -4 is -8. Times -1 turns to +8. These are my down diagonals. Okay, now let's do the up diagonals. Alright, the up diagonals are like this. Okay, up diagonal, up diagonal, up diagonal. Okay, so that's 30 times 2, 60. Okay, 4 times 3 is 12, so -12. And then 0, anything times 0 is 0. Okay, so down diagonals minus up diagonals. Now I could type this entire thing into my calculator if I wanted to, or I could do it in stages. But 18 plus 8, for example, is going to be 26. And 60 minus 12 is going to be 48. And 26 minus 48 is going to be -22. So this is the determinant. Notice that I'm not automatically multiplying by plus or minus 1/2. That was what we did when we were finding the area of a triangle. Okay, that we're not finding the area of a triangle right now. All right, what else you got? 23. Okay, last time I tried to solve the system using matrices, it backfired, but hopefully this will be a normal answer. So let's give it a try. What you need to do is rewrite this as a matrix equation like so. So we will do 3, 7, 1, -2. Okay, this is the coefficient matrix. And then we need our variable matrix, which is just x and y. And we're going to set that equal to our constant matrix, which is 5 and 6. Everything that I'm writing down, you need to write. When I grade this, I'm going to be giving you points for every part of this. So if you skip a step, you're losing points, even if you have the right answers. Okay, so I have to see this matrix. So many points for having this matrix equation. You must label them the way I'm about to label. So this is matrix A, label this matrix X, label this B. You must write that down. Okay? Then I want to see the following two equations. So what we have here is AX equals B. Write that down. Now the result of this, if I want to get X by itself, it's going to be like this. X is going to equal A inverse times B. I must see all of this on your paper. If any of this is missing, it's minus points, minus points, minus points. Okay? Alright, because this is the theory. So, basically, if we want X, which is what we're looking for, then we need to do A inverse times B. Okay? So that's what we're going to do, but so that means we need to find A inverse. Now I'm going to change colors and do that off to the left. So I need A inverse. I have B, so I need A inverse. So over here, off to the side, I'm going to find A inverse. Okay, how do I find A inverse? Well, first I need the determinant. Okay, the determinant of A is going to equal the down diagonal minus the up diagonal. So that's -6 minus 7. Okay, so that means that the determinant of A is -13. Okay, keep that in mind. Now, so to find the inverse, I'm going to start by doing 1 over -13. Alright, now here's where I reverse negate. Alright, when I talk about reverse negate, I'm doing the down diagonal and then the up diagonal. I'm going to reverse the down diagonal and negate the up diagonal. So reversing means I'm going to switch these places. So I'm going to do -2 here and 3 here. That's the reverse part. Negating means doing the opposite sign. So that means the +1 and 7 will become -1 and -7. Now, what if this had already been a -7? Do I just keep it a -7? No, I would switch it to a positive. So when I say negate, it means put the opposite sign. If it's negative, make it positive. If it's positive, make it negative. So there, I reversed and negated, and I did the 1 over the determinant. This just means I'm going to wind up dividing everything by the determinant. Now, if I were you, I would not make all the fractions right now. I would save that for later. Okay, so now it's time to do the rest. So keep in mind that we're trying to do A inverse times B. So let's get back to that. Okay, I'm just going to put a line here. So we are attempting to do A inverse times B. Okay, now A inverse is this purple thing over here. This is A inverse. It's 1 over -13. Okay, and then I've got my -2 and my -7 and my -1 and my 3. That is A inverse. In fact, maybe I'll move this over. Whoa, it gets the line too? I don't want that. Ah, I'm just messing up everything. Okay, that was a lot of work just to move this over. Okay, fine. This purple stuff is A inverse. And now we need B. Okay, B is this blue thing right here, so I think I'll switch to blue to make a point. Okay, so B is the 5 and the 6. So, let me put my line back here again. So, according to our theory, our solution is going to equal A inverse times B. So we found A inverse here in purple, and then now we're going to do A inverse times B. But it's simpler if I do this part of the matrix. If I just do this matrix, the purple matrix times the blue matrix, and then divide everything by -13 at the end. So that's what I'm going to do. So check this out, people. This is a 2 by 2 matrix. This is a 2 by 1 matrix. So that means my final answer is going to have the shape 2 by 1. So my final answer is going to be in this form. It's going to be like element 1, 1, element 2, 1. Okay, so this will be matrix X. Okay, because A inverse times B should equal X. Alright, so all I have to do is find element 1, 1 and element 2, 1. Well, okay, I kind of messed up a little bit. It won't fully be the answer until I divide everything by negative 13. Okay, so it'll be the solution after I divide everything by negative 13. But anyway, let's start finding these. So element 1, 1, here we go. Sure, I feel like changing colors. So element 1, 1, that's row 1 times column 1. So row 1 is my negative 2 and negative 7. Column 1 is the 5 and the 6. Alright, that's my row 1, column 1. So that is negative 10 and negative 42. Put those together and I get negative 52. Okay, so that's element 1, 1. Okay, so I'm just going to go ahead and put that in there. Alright, so that's negative 52. Alright, that is not the answer. I will have to divide by negative 13 at the end. But let's go ahead and find one more. I think I will use a different color. You know what? I'm going to use like pink. Plum pink. Okay, so element 2, 1. Okay, that's row 2, column 1. So that's negative 1, 3, and good old column 1. Okay, that's 5, 6. So that's going to give me negative 5 and 18. That's 13. Okay, so that's element 2, 1 that we just found. Okay, so that is going to be 13. Alright, but for the final answer, I need to divide everything by negative 13. Okay, so that's going to give me, for the final answer, alright, 13 goes into 52 4 times. So this is going to be 4. I just did negative 52 divided by negative 13. So that's 4. 13 divided by 13 is 1. So this will just be negative 1. Okay, so this is matrix X. Okay, which means X is 4 and Y is negative 1. So let's go ahead and put that as our final answer. Okay, so this means that X equals 4 and Y equals negative 1, which we could also write as an ordered pair, 4 comma negative 1. Okay, and that is how you use matrices to solve a system. Okay, you definitely will be expected to do that on the test. Alright, for number 25, find the inverse if it exists of these two matrices. Okay, so I'm just going to draw a line and find these two matrices. Now when they say if it exists, what would it take for a matrix not to have an inverse? How can it not exist? Okay, if the determinant of a matrix is 0, that would mean that there is no inverse. Okay? So that's why they say if it exists. So if either one of these has a determinant of 0, we'll say the inverse does not exist. Okay, so let's remember how we find the inverse. We start by finding the determinant. Alright, so the determinant is going to be the down diagonal minus the up diagonal. So the determinant is 15 minus 14. Okay, so the determinant for that one is 1. Okay, I'll call this matrix B. So the determinant of matrix B, again, down diagonal minus up diagonal. So that's going to be 24 minus 24. Uh-oh. 24 minus 24, that is 0. Okay, it's what we just talked about. Whoa, that's supposed to be yellow. That is 0. If the determinant is 0, then that means the inverse does not exist. So we will just write inverse does not exist. Now, could you have put undefined? Yes. Alright, but this one, with a determinant of 1, the inverse does exist. So normally we would do 1 over this. Okay, but 1 over 1 is just 1, so it's really irrelevant. But this is the stuff when you're doing the inverse, that's when you reverse and negate. So reverse negate! Reversing these means -5 and -3. Okay, I just reverse those. Negating these means -2 and -7. Reverse negate. And that's really it. So that means A inverse, because normally I'd have to divide everything by the determinant, but dividing by 1 isn't changing anything. So it's just -5, -7, -2, and -3. Okay? So that's the inverse of matrix A, and matrix B does not have an inverse. Okay, what else you got? Oh, you know what? I think there's the last one. Okay. But it's a doozy. It's a doozy. Word problems and such. Well, at least I gave you the inverse matrix in case you don't have a graphing calculator. We need to write some equations. So before taxes, 2 pairs of jeans. Okay, I'll use J for jeans. So 2 pairs of jeans and a t-shirt cost $59.48. All right, so can you see where this equation is coming from? 2 pairs of jeans, that's 2J. Okay, and a t-shirt, so that's plus 1T or just T, and that's costing $59.48. So boom, there's your equation. So we're gonna have to just make 3 of those. So here we go. So we have 2J plus T. I'm leaving a space because there's going to be there's sandals, and that's going to equal $59.48. All right, that's my bell for lunch, but I'm just going to finish setting this up. Okay, let's see what else. 2 t-shirts and, okay, so far we have 2 t-shirts, so that'll be 2 t-shirts and a pair of sandals. Okay, that's another thing, so I'm going to put plus S cost $33, so 33. All right, notice I'm lining things up because that's how you do for a matrix. So make sure you line up your T's and your J's and your S's. All right, now 1 pair of jeans, 1 shirt, and 1 pair of sandals cost. Okay, so it's 1 of each. So 1 pair of jeans, 1 t-shirt, 1 pair of sandals. Okay, line them up, and that's going to cost $48.49. Okay, so this is our system of equations. We are going to use matrices to solve this. All right, I'll just do a couple more steps here. Remember to use zeros for your missing variables. So the matrix equation would look a lot like this. All right, first we're going to have like a 3 by 3 matrix. That's like 2, 1 for the T there, and then 0. And then 0 and 2 and 1 for the S, and then 1 and 1 and 1 for the J, the T, and the S. Okay, that is our coefficient matrix. And then the variables are, in order, J, T, and S. So J, T, and S. Jeans, t-shirt, sandals. And that should equal the constant matrix, which is 59, 48, 33. All right, I could put 0.00, but it's not really needed. And 48.49. That is our constant matrix. All right, everything I'm writing down, when we have problems like this on the test, you must show it. So this is matrix A. You must label it. We will call this matrix X, our variable matrix. And this is matrix B. You must show this, okay? All right, because then below that, you're going to put this little theory. All right, A times X equals B. Therefore, X is equal to A inverse times B. If I do not see this red stuff, okay, this red analysis on your paper, you're going to lose points for that. Okay, even if you get the right answer, I need to see what you were doing. I need to see the theory of it. A times X equals B. That's what we have here. So we're doing X equals A inverse times B. So fine. That means we need to do A inverse times B. You do not know how to find the inverse of a 3 by 3 matrix. When it was a 2 by 2 matrix, we do that all day, every day. Okay, you do it like this. All right, but when it's 3 by 3, you don't know how to do it. So I'm either going to give you a graphing calculator to find it, or I'm just going to give it to you, like I did here. So please understand that when I say, look, inverse coefficient matrix, I'm telling you that this is the inverse of the coefficient matrix. Okay, A is the coefficient matrix, so this is the inverse. So I'm giving you A inverse. And remember, X should equal A inverse times B. Okay, that's what we're doing. So we have A inverse, we just need to multiply times B. Okay, and just to save yourself some writing, if I were you, I would just, I would just label this A inverse and, label this B. So now here we are doing A inverse times B. Okay, let's see. Okay, so here's our A inverse that we were given. And here's our B, which of course came from our constants. So now we just need to do A inverse times B. Now remember our analysis. Okay, this is a 3 by 3 matrix. This is a 3 by 1 matrix. That means the final answer should have the form 3 by 1. Okay, so you should set up for yourself a 3 by 1 answer. All right, so in other words, we're expecting X to equal this 3 by 1 matrix. Okay, so it's like element 1, 1, element 2, 1, and element 3, 1. All right, I'm so excited. I'm just going to go ahead and do one of these, and then I have to go eat lunch. Okay, so let's do element 1, 1, for example. Leave myself as much space as I can without covering it up. Okay, I'm going to do it over here. So element 1, 1, that's going to be row 1 times column 1. So row 1 is 1/3, negative 1/3, and another 1/3. Okay, that's row 1. Okay, column 1 is this 59.48, 33, and 48.49. Okay, so there's our row 1 times column 1, element 1, 1. Okay, now if I set this up, remember as I multiply, I'm really just multiplying by the numerator. So this is going to be 59.48 over 3, and this is going to be negative 33 over 3. Okay, obviously that's negative 11 if you're smooth like that. And then this one is going to be 48.49 over 3. All right, remember to get that final result, I need to add these up. I recommend the TI-30 XS Multiview. Okay, so here we go. 59.48 over 3. Get out the bottom. Plus, now, I cannot bring myself to type 33 over 3. I just can't do it. So I'm going to put negative 11 and hope that you know that 33 divided by 3 is 11. Plus 48.49 over 3. Wait, I feel like, did I miss a digit? No, it's there. Phew, scared me. All right, if I hit enter, boom, that should give me one of my answers. So $24.99. $24.99. So that is element 1, 1. Okay, so I can just go ahead and put that in there right now. So that was $24.99. Okay, you do that 2 more times, and that will give you the price of each item. So far, I've got jeans. All right, and I'm gonna go eat lunch, and I'll have to finish this video later.